Hey y'all, today we are on pages 11 and 12 in our notes, and we're going to learn the third and final way on how to solve a system. So we talked about how to graph, which is, probably the easiest way if the numbers are pretty easy, where there's not a big y-intercept, there's no decimals. We've been graphing for a while, so that feels comfortable. Substitution, it works if you have one equation that's solved for and one isn't. So then it can be easy just to substitute it in. And then the final method will be by elimination. And this one I actually love the most. It takes a little while to understand, I think, the concept, but once you get it down, I think it is the quickest and the most efficient way. Obviously, we're going to talk about different ways when we should use a method rather than using the other, but we'll get to that later this week. So Nikhil is solving a system of equations shown and decides he will try a new strategy. So we have negative 2x plus 4y equaling 8 and 6x minus 4y equaling 0. So we're just going to try to answer these questions and see if we can come up with a different method. So it says, what is the sum of the two equations? So sum means to add. So I'm just going to add these together. Okay. Negative 2x plus 6x, I'm going to add vertically. That would be 4x. Okay. 4y plus negative 4y would make 0y, so that kind of eliminates. That's interesting. And 8 plus 0 is 8. So when we add these together, we just have 4x equaling 8. And then so it says, what happened after adding the equations? Well, it looked like the y values created a 0, or they eliminated from each other. Okay. So after we eliminated one of them, we have 4x equaling 8. So if we were to solve that, we would divide by 4, and we would just get that x equals 2. If Nikhil knows the value of one variable, how could we find the value of the second variable? So if we know that x equals 2, we could use either equation, and we could substitute in x equals 2 into either equation and solve for y. Because we know the x coordinate, we just don't know the y coordinate. So I'm going to use the bottom one just because I want to. So 6x minus 4y equaling 0. We just figured out that x equals 2 though, so I'm going to substitute in 2 for x. 6 times 2 is 12. Now I just need to solve for y, so I'm going to move the 12 over with subtraction. And then I'm going to divide by negative 4, and I get y equals 3. So the solution to this system would be 2, negative 3. Finally, it asks to substitute the x and y values into the original equations. So we will go ahead and do that. So in the top one, we have negative 2x plus 4y equals 8. So negative 2 times my x coordinate, which is 2, plus 4y, 4 times 3, equals 8. Negative 4 times 2 is negative 4. 4 times 3 is 12. And negative 4 plus 12 equals 8. So that creates a true statement. The other one is 6x minus 4y equaling 0. 6x, 6 2's, minus 4y minus 4 3's equaling 0. 6 times 2 is 12. Negative 4 times 3 is negative 12. 12 minus 12 is 0. So when we plugged in this solution, they created two true answers. So they are the solutions. Whoopsie. So this way of eliminating something is the final way we could solve a system. So the method requires us to line up the like terms in the equation. So I like to think if they're both in standard form, this is when I definitely use elimination. Okay. So we will add or subtract the equations to eliminate the variable, one of the variables, with opposite coefficients, and then we'll solve for the remaining variables. So that's what we'll do here in a second, practice a couple. Then we will substitute in the answer that we just get into either one of the equations to get the second variable. And then we will make sure that we write our solution as an ordered pair, and we will just check our answers to make sure that it makes sense. So I like to use elimination when they are both in standard form. So you'll look at all three of these examples. All of these equations are in standard form, so our variables line up. That's what I mean by the first step. Make sure that they are lined up on top of each other. Okay. I look for opposite coefficients. So if I look at the 3x, the one below it is a negative 3x. And so if I add those together, I know that something's going to eliminate because that would make a 0. So I'm just going to add them together. 3x with a negative 3x would make that eliminate, make a 0x. 2y plus 4y is 6y. 16 plus 14 is 30. So our equation is 6y equals 30. I would divide by 6, and I would get y equals 5. So in my solution, I know that my x-coordinate is 5. Then I know the answer to one of them, so I'm going to pick either equation and plug in y in for 5 and see what my x value is. So I'm going to use the top one just because there's no negatives. So I have 3x plus 2y, so 2 5s, equal to 16. 2 5s would make 10. Then I would move the 10 over with a negative. 16 minus 10 is 6. And then 3x is equaling 6. I would divide by 3 and get x equals 2. So my solution would be when x is 2, y equals 5. Then I would just check my work to make sure that it makes sense. So the first one, we have 3 x's, so we have 3 2's plus 2 y's, 2 5's, and that should equal 16. 3 2's make 6, 2 5's make 10, and 6 and 10 make 16. Okay. My other equation, just to make sure, I have negative 3 x's, so I have negative 3 2's plus 4 y's, 4 5's should equal 14. Negative 3 2's would make negative 6, 4 5's would make 20, and negative 6 plus 20 does equal 14. So if we were to graph these, they would cross right at 2, 5. So the elimination method actually is a very effective way if they are both in standard form. So number 2, they're lined up, okay? The x's would not eliminate, but the y's would because we have a positive y and a negative y. So I'm going to add them together. Okay. 7x plus 3x is 10x's. Y minus y eliminates. Negative 2 plus 12 is 10. So we have 10x equaling 10, which means that x equals 1. So in our solution, we know that the x-coordinate is 1. We just need to figure out the y-coordinate, so we can plug it into either equation. I'm going to use the top one again. It doesn't really matter. So I have 7 x's, so 7 1's plus y, and it has to equal negative 2. So 7 1's would make 7. And then I would move the 7 over with a negative 7, and that would make negative 9. Whoopsie. Okay. So then I'm going to check my work just to make sure it makes sense. Again, you could use just your brain to make sure it makes sense, but I'm going to write it out for you guys. So 7 1's plus 1y, 1 negative 9, should equal negative 2. 7 minus 9 equals negative 2, so that is true. 3 x's, 3 1's, minus a negative 9 minus my y should equal 12. 3 1's is 3, a negative 9 is a positive, and 3 plus 9 is 12. So this is the solution for this system. So go ahead and try number 3. I'm going to have you guys try to solve it all the way out, and then you're going to try to type in your answer. Okay, so hopefully you have tried this. You would add these together. You would notice that the x's would eliminate. Negative 3y plus 5y is 2y, and negative 7 plus 1 is negative 6, which means that y would equal negative 3. Okay. Then to figure out the x, again, you could use either one. 4x's minus 3 negative 3's need to equal negative 7. 4x plus 9 equaling negative 7. 4x equals negative 16. X equals negative 4. Then to check yourself, you could just self-check. 4 negative 4's minus 3 negative 3's should equal negative 7. That would be negative 16 plus 9, and negative 16 plus 9 is negative 7. Negative 4 negative 4's plus 5 negative 3's should equal 1. That would be 16 minus 15, and that does equal 1. Okay, now on the back page, in systems where neither of the variables are ready to be eliminated or they don't have opposite coefficients, what we're going to do is we're going to manipulate the equations by multiplying them, either one or both of them, by a constant in order to create opposite terms. When multiplying by a constant, remember to multiply every term within the equation. Okay, so this one you get a lot of freedom. Okay, so I look and they're both in standard form, which means the x's and the y's and the numbers line up, which makes elimination the most effective one. And then I like to just ask myself, what do I want to eliminate? What would be easier to eliminate? Well, I notice that this is already a negative 2y, and this is a positive y. So basically, if this was a positive 2, that would eliminate. So what I'm going to do is I'm going to make that a positive 2 by multiplying everything in the second equation by positive 2. So 2 times 4x is 8x. Okay. 2 times y is 2y. And 2 times 16 is 32. Just have to remember you multiply every single thing by 2. So now this is an equivalent equation. And then if I put the other one below it, I notice that now the y's are opposite each other and we could just eliminate them. So I will eliminate them. I would create 11x's. Whoa. I would create 11x's equal to 22, which means that x equals 2. Then to figure out what y is equal to, you could pick one of the original equations. You could use the new manipulated equation. You have a lot of freedom with this one. I'm going to use the bottom original one. So I know 4x's, just figured out x was 2, plus y equals 16. So 4 2's would make 8. And that means that y would have to be 8. So my solution is 2, 8. So to self-check myself, 3 2's minus 2 8's should equal negative 10. That would be 6 minus 16, and 6 minus 16 does equal negative 10. 4 x's, 4 2's plus a y should equal 16. That would be 8 plus 8, and 8 plus 8 does equal 16. Okay, so now this middle problem, we have 2x plus 2y equaling negative 12 and 6x minus 3y equaling 9. Okay, so I see that none of them is like a 1 like this one, so we're gonna kind of have to like figure something out. I already know that one of this is a positive and one is a negative. So if I think about basically least common multiple, I think of 6. So if one of this was a 6y and this was a negative 6y, they would eliminate. So I'm going to make them 6y's. So I'm going to know, I need to know that I could multiply this by 3, and I'm going to multiply this one by 2, because the goal is to make 6y's. So I'm going to multiply this top one all by 3. So I would get 6x, 6y, and negative 36. Okay. Then I'm going to multiply the bottom one all by 2's. So I would get 12x minus 6y equaling 18, which is exactly what I wanted because now the 6y, the negative 6y would eliminate. Then we would be left with 18x, and that would be a negative 18. So 18x equaling negative 18, that means that x equals negative 1. Then to figure out what the y coordinate is, again, you can pick whichever one you want. I'm going to pick this one just because I want to. So 2 x's, so 2 negative 1s plus 2y equaling negative 12. So 2 negative 1s would be negative 2. I would add the 2 and get negative 10. I would divide by 2 and I would get y equaling negative 5. So my solution would be negative 1, negative 5. And again, I can always check myself. 2 negative 1s plus 2 negative 5s should equal negative 12. Negative 2, negative 10 does equal negative 12. So we are awesome. 6 x's, 6 negative 1s minus 3 negative 5s should equal 9. Negative 6, positive 15 does equal 9. So boom, we are correct. So I want you guys to go ahead and try number 6. There is multiple ways to solve number 6. I want you guys just to try it. And then you'll check with me. Again, the way I solved it might be a little bit different, but hopefully you get the same solution. Okay. So for this one, we have positives and negatives in both of them, so you get kind of a little bit of freedom. I'm just going to multiply. I'm going to make the y's eliminate just because that's what we've been doing. So I see a 3 and a 4, so I think of the least common multiple, which would be 12. So I'm going to multiply the top one by 4 and the bottom one by 3. Okay, so then I should get negative 8x plus 12y equaling negative 48. Then I would get 9x minus 12y equaling 30, 48. Okay, so these eliminate, and I get 1x equaling 0. Well, that means that x is 0. Okay, so then my y coordinate would be 3 zeros minus 4y equaling 18. So that'd be 0 minus 4y equaling 18. I would divide and I would get negative 4.5. So my solution would be 0, negative 4.5. Okay. Again, I'm always going to check to make sure I did it right, especially since we have a 0 and a decimal. I want to make sure that I did do it right. So I have negative 2 zeros plus 3 negative 4.5s. And I get negative 12. So see, I already messed up. Ah. Okay, there we go. See, everybody makes mistakes. I just make a lot, you know? Okay. 3 times 18, shouldn't do that in my head. We get 6. So that would be 12. And that would be, 12. Okay. Then we would get negative 4y equaling 6, and we would get y equaling negative 1.5. And x equaling 6. Okay, so let's see if that is the right answer. Okay, so negative 2 6s, negative 3 times 1.5 would be negative 4.5. Oh my gosh, I can't do math today. 3 times 6 is 18. That would be... Sorry guys, I can't do math and I'm not going to change my video. So you guys are just going to learn that it's okay to make mistakes. So 3 times 6 is 18. So then I would take away the 18 and I would get 0, which means that y equals 0. So I have 6 comma 0. I feel very confident with this now. Sorry about that. All right. So then if I have negative 2 6s, that's negative 12. If I have 3 zeros, that is 0, and that would make negative 12. And then if I have 3 6s minus 4 zeros, that would equal 18. 18 minus 0 does equal 18. So we know we are right. So that is just a great reason why we should probably check our work every time, because I mean, it's not like I don't know what I'm doing if you just sometimes make a little calculation mistake or make 2, you know? All right, Lola is solving a system of equations by using elimination. Lola thinks the equation should be added together to eliminate the variable, the x variables. Okay, well, if we add these together, we would make 8x. Those would not eliminate. So we cannot subtract. We cannot add, because that would make 8x plus 4y equaling negative 12, which did not help us at all because that does not eliminate anything. Okay, so what is a possible first step for Lola to make? Well, they are 4 x's, so we could multiply one of them by negative 1. And make it negative 4x plus 2y equaling positive 18. Because then they would eliminate. They would make 8y's plus 24, which means that y would equal 3. Then 4x's plus 6, I'm using the bottom one, 6 3's would equal 6. 4x plus 18 equaling 6. 4x, take away the 18, I would get negative 12, and then x would equal negative 3. So my solution would be negative 3, positive 3. Okay. 3 popcorns and 2 sodas from the concession stand are sold for $13. 6 popcorns and 3 sodas are cost $24. If X represents the cost of popcorn and Y represents the price of soda, the situation can be represented by the system below. Solve the system using elimination to find the price of popcorn and the price of a soda. Okay, so we need to basically solve this. I noticed that we have 3 and 6, we have 2 and 3. So I think making this a 6 would probably be the easiest way. And if it was a negative 6, it would eliminate right away. So I'm going to make this a 6 or a negative 6 by multiplying by a negative 2. So then that would make negative 6x. That would make negative 4y. And that would make negative 26. So then these would eliminate. This would become negative 1y. And this would become negative 2. So y equals 2. Then to figure out what x is equal to, we would do 3x's plus 2y, so 2 2's equaling 13. 2 2's would make 4. We would take away the 4 from 13, get 9. We would divide by 3 and get 3. So x equals 3, y equals 2. So x represents the price of a popcorn. So popcorn is $3. And y represents the price of a soda. So soda is $2. Okay. Describe when you would be most likely to choose the method of elimination to solve a system of equations rather than one of the previous methods. So we've learned how to solve by graphing, by substitution, and by elimination. Okay. So what I want you guys to do is you guys are going to answer this question at the end of your ed puzzle, and then there's going to be some Delta math that kind of guides you through this step, so then we can practice a little bit more tomorrow. See you guys tomorrow.